Hi class, we're continuing to work with polynomials in chapter 8, and today's lesson is on positive and zero exponents. So here we have an example of x to the fourth power. X to the fourth power means x times x times x times x, where 4 is the exponent and x is the base. Now, I want you to consider this product, x to the third power, or x cubed, times x squared. So that is the same as x times x times x, which is x cubed, times x squared. When you multiply this, you have 5 x's, and the exponents are added. So we have 3 factors plus 2 factors equal 5 factors. Therefore, in any circumstance, when the bases are the same, you are going to add the exponents. This is called the product rule. When bases are the same, you add the exponents. Okay? So these bases are being multiplied, and then you add the exponents. Rule 1 of exponents can be extended to include more factors. So we have a same base of x here, x to the power of a, x to the power of b, x to the power of c. And you will just add these exponents for your answer. So let's work through a few examples. First example is 10 to the 7th power times 10 to the 5th power. We're going to apply the product rule where the bases are the same. So we have 10s right here. Our bases are the same, so we're going to add the exponent. So this is now 10, 7 plus 5, which equals 10 to the 12th power. And for your homework, you will actually give me the full answer. So this is 10 to the 12th power, where we have 12 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You want to add your commas. This is 1 trillion for the answer. Now here again, we have the same base, and our exponents are all different. We're going to add these exponents. So this is 2. This, if you don't see a number, you are going to assume that it is a 1. Okay, so 2 to the 1 power plus 3 plus 2. And this is 2 to the 6th power, which equals 64. Now, here we have still the same base and different exponents, but they're variables. So we're going to add our variables, 2 to a plus b. And this is my answer right here. And then x cubed times y squared. Here our bases are different. So the product rule does not apply to this, and our answer would stay the same. This would be our answer. Okay, word of caution. 2 squared times 2 cubed is not 4 to the 5th power. Okay, you do not multiply your bases. Let me show you. 4 to the 5th power equals 1,024. Okay, so this is very different than when you apply the product rule correctly. When the bases are the same, you are going to add the exponents only. And so this is 2 to the 2 plus 3rd power, which is 2 to the 5th power, which equals 32. So these numbers are completely different, and this is the correct answer. Okay, so just remember, do not multiply the bases when they are the same. When a power is raised to a power, the exponents are multiplied. This is called the power rule. So remember when I told you, when you have a number or variable within parentheses, The exponent applies to the whole thing, okay? So look at this example here. I have x squared raised to the third power. Okay, so this 3 applies to everything inside of the parentheses. So this means that it is x squared times x squared times x squared. Okay, you want to multiply the exponent by what it is being raised by. So here we have x squared to the third power. 2 times 3 is 6. So my answer is x to the 6th power. This is the power rule. Let's work on a few examples. So here I have x to the 5th power raised to the 4th power. So this is the same as x. 5 times 4, which equals x to the 20th power. Now here I have x in parentheses and 4 raised to the 4th power. So I don't have a number inside. That means x to the 1st power times 4, which equals x to the 4th power. Okay, now y to the 4th power raised to the 3rd. This is going to be y. 4 times 3, which is y to the 12th power. Okay, 10 to the 3rd power times 2. This is 10. 3 times 2 is 6. So we are going to add 6 zeros. 1, 2, 3, 4, 5, 6. And then I'll add my zeros for 1 million. Okay, here I have 2 to the a power raised to the b power. So I have 2 to the a times b, and this is 2ab when multiplied together. Okay. Quotient rule. When like bases are divided, the exponents are subtracted. So you can see in this diagram here, I have the same base of x. I'm going to subtract my exponents. In this example, x to the 6th power divided by x to the 2nd power. And I have demonstrated here that this means 6 x's across the numerator and then 2 x's for the denominator. Now I'm going to cancel these out. I've got 1 here and 1 on top. I'm going to cancel that out. I'm going to cancel the next set out. I am left with x to the 4th power, which is the answer. You can also demonstrate this by x to the 6th minus 2 equals x to the 4th power, which is the answer. Let's do some more examples. So I have y to the 3rd divided by y. Now remember when I said if you don't see an exponent there, it is known that it is 1. So I have that demonstrated here. Y to the 3rd divided by y to the 1st. This is going to look like y to the 3rd minus 1, which equals y to the 2nd power. 10 to the 7th power divided by 10 to the 3rd. This is 10 to the 7th minus 3, which equals 10 to the 4th. Let's add our 4 zeros. This is 10,000 is our answer. Example here at the bottom, x to the 5th divided by y to the 2nd. Now notice the variables are not the same, so we cannot apply the rule, and the answer will be left as it is. Okay, 8x cubed divided by 2x. So we have the same basis of x. We can break this down and simplify this. Okay, so we can simplify 8 over 2 because 2 goes into 8 4 times, and we can then subtract 3 minus 1, which is 2. So this becomes 4x squared. That is my answer. Let's do another example. 6 times a cubed times b to the 4th power divided by 9 times a times b squared. So I have 6 over 9 times a cubed over a times b to the 4th power divided by b squared. So I can simplify. We've got a common factor between 6 and 9, which is 3. 3 goes into 6 2 times. 3 goes into 9 3 times. So my fraction would be 2/3. Now here I have 3 minus 1, because a cubed minus a to the 1st power is 3 minus 1, which is 2. So this is a squared. And then b to the 4th power minus b to the 2nd power, this is 4 minus 2, so which is 2, and then this will be b squared. So you can leave your answer to look like this. It is also correct to write it like this. Okay, either are acceptable. Now I have 2 to the a power divided by 2 to the b power. Bases are the same, so let's apply the quotient rule where we subtract the exponents, and it will simply be this, because we are working with variables, 2 to the a minus b power. That is my answer. I have a word of caution for you and a short little lesson here. So x to the 4th divided by x to the 4th. This is what this looks like. X times x times x times x, that's 4 x's, and again x times x times x times x. Now all of these will cancel, okay? And this is the same, or it's equal to 1. Now what happens when we apply the division rule? So this would be x to the 4th power minus 4, which equals 0. So this is x to the 0 power. Now, x to the 0 power equals 1. This is why any number to the 0 power will equal 1. Let's do one final example, 6 times x to the 0 power. So like I said, x to the 0 power is 1. So 6 times 1 is 6, and that is the answer. Okay, hope today's lesson was fun and challenging. Let me know if you have any questions.